S-CP.A.4, worksheet number 2, all about two-way frequency tables part 2. And actually you may want to look back, or I'll include the previous one as well. But basically they're the same. I'm just going to do some more problems and add a little bit more calculation to it. Here's a little table about those that own smartphones, you do or you don't. Those that own an iPod do, that don't. And the data that was selected from a survey. So I just want to go through some quick calculations for you, just to show you how a two-way table works. What's the probability of owning a smartphone is 38, in this group at least, 38 out of the 50. A very easy little calculation, just the sum out here in the margin, the marginal value of 38. We learned the probability of a smartphone and owning an iPod. And is a multiplication statement. So probability of smartphone is 38 out of 50. And owning an iPod is 28 out of 50. And a quick little calculation of that. So 38 times 28 is 1,064 out of 2,500 is that probability. We'll come back to that guy in a minute, but basically it's just the multiplication of those. Now an OR statement means to add. What's the probability of not owning a smartphone? That's this category here. So is 12 out of the 50. Added to not owning an iPod, that is this group, is 12 out of 50. But you'll notice, and that's why I circled this, you'll notice that this guy right here, the 4, is double counted because of the column and row there. So I'm going to subtract the 4 that I counted twice. So I get 34, so that would be 30 out of 50. Now let's do a conditional statement. Ooh, a two-way table is so awesome for a conditional statement. It says, given that you have an iPod, So what that means is I am now only in the red zone here. I know I have an iPod. Given that that happened, what's your chances of owning a smartphone? It's just 20 out of 28. Notice it's out of 28 because we're not out of the whole group anymore. We've reduced it down to only those that own an iPod, and by that case the probability is 20 out of 28. So here's a group. We do not own a smartphone. So let's, oh, it's already kind of highlighted. There it is, okay. And so it's going to be out of 12 because I know that I don't own a smartphone, but I do not own an iPod. Yeah, so it's 4 out of 12. Now let me show you one more thing about this. You can determine whether these guys are independent or not, whether owning a smartphone and owning an iPod are independent of each other. Maybe they are dependent, I don't know. Kind of makes sense to me. If you're a techie, you own the cool phone and you'd own the important music option, but maybe not anymore because your phone is your music option. But here's a way to test it. Look at this. This is 38 out of 50. This is 20 out of 28. Now if those values are the same, right, the probability of smartphone given an iPod and the probability of smartphone, if those numbers come out to be the same decimal, then they were independent. The one, this guy did not change that. So 38 divided by 50 is 0.76, remember that number. And 20 divided by 38 is 0.52. Those are different. So there is a dependent relationship going on in here somewhere. And it makes sense that things about technology, owning one or not owning another, would cause some of that. Let me just quickly do a similar thing here. Let's do the marginal values, 24, 8. This is 32, 15, and 17. 32, everything adds up. Let's test if these are independent. Let's test if the probability of boy times the probability of chocolate. Let's see if that's the same as the probability of boy and chocolate. So boy and chocolate is right there, 14 out of 32. And let's get that as a decimal. 14 divided by 32 is 0.4375. Now if I take the probability of boy, which is 17 out of 32, and I multiply it by the probability of chocolate, which is 24 out of 32, I get 17 times 24 divided by 32 divided by 32 comes out to 0.398. These numbers are not the same, and so they are not independent. They have to be dependent on each other. So knowing the gender does impact your knowledge about whether what flavor they pick. Here's another way to test it. Here's the probability of boy, and let's test it with the probability of boy given that chocolate was selected. If these two answers are the same, then they are independent. They won't be because we've already tested this, but let's just test it a different way. Probability of boy is 17 out of 32. Probability of boy given chocolate. Okay, so given that chocolate has been selected, given that chocolate's been selected, a boy would be 14 out of 24. 17 divided by 32 is 0.53. 14 divided by 24 is 0.58. These are different. They are not independent. I love two-way tables. They're so visual and make good connections for you.